Hi, and welcome to Electric Fields Lesson 2b. The question you had was, what are going to be the field lines between a negative and a positive charge? Now we're imagining these are just sort of suspended in space, so even though they would sort of accelerate towards each other, there would be a force there, we're imagining they're just sort of stuck there, and we're now going to draw the field lines around them. So the thing to do again is imagine, what would you do if you were a positive charge at that point? Let's start with the points here and here, because they're furthest away from the middle, which is probably going to be the most complicated. Well, if you were a positive charge here, you just slam into the negative, and you'd be really happy about it. Similarly, if you were here, you just push straight away from this positive. Similarly, we can draw these in here, and these out here. The question is, what's going to happen in the middle? Well, if you imagine a sort of straight line in between these two, if you're a positive charge, you'd actually be being accelerated away from the positive and towards the negative. So what we're going to get is just a nice line like this. Similarly, if you were here, you'd start to be pushed away from the positive, but then you'd be picked up by the negative field and you'd be pulled into the negative charge. So what you're going to end up with are sort of looping lines that look like this. And similarly here, like that. And so these are the field lines between a positive and a negative charge. I'd just like to take this moment to talk about two other little things to do with electric fields in general, just some other foundational principles that I wanted to put in here. The first is, what is charge when you get down to it? What's going on there at a very fundamental level? Pause this video and just imagine to yourself for a second, if someone asked you what is charge, how would you respond? My answer would be this. Everything is made up of subatomic particles called quarks. Quarks have both mass and charge. It's just a fundamental thing that they have. And that whenever you get an imbalance of the charge in the quarks, then the particle will have charge. Now we already know this, because a neutron is actually made out of charged quarks. It's just that because it's, I can't remember which way around it is it plus 2/3 minus a third minus a third? Yeah, you end up with no overall charge. Whereas a proton, because it has plus 2/3 twice and only minus a third once, you end up with plus 1 charge, so overall it is charge. So charge, when you get down to it, is just a thing some particles have, and they generate electric fields. But that shouldn't be that surprising, because particles also have mass, and that generates gravitational fields. So it just turns out there are some properties of particles, some fundamental things particles have, which means that fields start to form around them. The second thing I just wanted to check in was with ideas about potential energy. So the definition of potential energy is exactly the same. How much energy would it take for a test positive charge to get from infinity to that point in the field? So if I was to put 2 points in the field here, point 1 and point 2, one of these is going to be positive potential energy and the other is going to be negative potential energy. Pause the video, have a little think, which one is which? To think about the answer, remember that we always define infinity as 0, and then we're thinking about how much work we've got to do to get to that point. If you're a positive charge and you're trying to get to point 2, well, you're moving closer to another positive charge, which means we're actually going to have to push you, which means we're going to have to do work, which means point 2 is going to have positive potential energy. Whereas to get to point 1, if you're a test positive charge, you're starting at infinity, where potential is 0, you're actually going to be pulled towards this, so rather than having to do work on the particle, the field will do the work for you, therefore this one is going to be negative. Armed with this information, I am sure this weekend's questions will be a doddle. Good luck and I'll see you next week.